What's going on again, everybody? This is Mr. Harris coming at you with some more math jewels. Today we're going to be talking about right triangle trig. Now, I know a lot of people get afraid when they hear the term trigonometry, but I want to make this a painless process. So let's go ahead and get it right into the examples. On the first two examples, example 1 and example 2, you're going to see that we're talking about finding a missing angle. And typically you'll see the Greek letter theta used to represent an angle that is unknown, but you can use the letter. This can be angle B as well. So we're going to start by simply looking at what they give us versus what we are missing. So in this case, we're trying to find this angle theta, and so we have to look at the relationship of the two sides of the triangle that are given in comparison to the angle theta. Now, the hypotenuse is always going to be directly across from the 90-degree angle. So segment AB, which has a length of 11, is our hypotenuse, and then segment BC, which has a length of 4.4, is our adjacent side. Now this adjacent side, notice it is attached or touching this angle theta. So with that being said, we are going to use the cosine of this angle theta. So I'm going to start by saying the cosine of theta is equal to, we know cosine is adjacent over hypotenuse, so we have 4.4 over 11. Now, when we look at this, we're going to also say the cosine of theta is equal to, we have to find out what 4.4 divided by 11 is, and that's going to give us 4/10. Okay, so from there we need to use the cosine inverse function because we are trying to find the measure of an angle. So I can say the cosine inverse of 4/10 is equal to my angle theta. And when I put this in the calculator, if I press second cosine in your TI graphing calculator, we'll get that 66.4 degrees equals the measure of angle theta. And that is how you would find the measure of this missing angle theta, or angle B for other matters, depending on how it's noted in the problem. I want you also to keep in mind that the way that I work out these problems, sometimes you may see them look a little different, but my point is just to give you all a little insight on how to solve them in general. On example 2, we're going to still find the missing angle, which is theta in this case. Now, here we have this angle right here is the adjacent side. I'm sorry, this side, segment BC, has a length of 3, and it is adjacent to angle theta because, once again, it's touching the angle theta. Now, segment AC is opposite or across from this angle theta, so this is going to be the opposite side. So based upon our trig functions, we're going to use the tangent because the opposite over adjacent side. So the tangent of theta is equal to 3 over 3. Now, when we simplify that, we get that the tangent of theta is equal to 1 because 3 divided by 3 is 1. So here in the calculator now, we say the tangent inverse, because we're trying to find the value of an angle, is equal to 1. So I'll go and I'll say the tangent inverse of 1 is equal to the value of angle theta. And in this case, theta is going to be 45 degrees. Now, one thing I want to point out in example 2 is the fact that if you recall your ratio of sides in the special right triangles, we know that the legs have the same value. So if you're a person that's familiar with those properties of the special right triangles, you may be able to recall immediately that this angle theta would be 45 degrees. But for those of you that may have trouble remembering those ratios of the sides for the special right triangles, this will help you. Also, you can see the videos that I have posted in reference to the special right triangles. I did an example on the 45-45-90 triangle as well as the 30-60-90 triangle.